Let's now explore the concept of a terminating line when its length is a specific wavelength, particularly quarter-wave and half-wave lines. A quarter-wave line is a well-known real impedance converter. The input impedance of a load ZL connected to a quarter-wave line is Z0 squared over ZL, which implies that if we need to convert a real value impedance ZL to another real value impedance ZX via a line, a quarter-wave line can accomplish this task. The line impedance Z0 should be designed as the square root of ZX times ZL, where Zx represents the target impedance. For example, 75 ohm is the standard impedance for a cable system. Suppose we are currently designing a cable TV system that requires interfacing with a typical 50 ohm system. In that case, we can use an impedance converter to convert the load impedance from 75 ohm to 50 ohm. To accomplish this, we can employ a quarter-wave line and design its line impedance as 61.2 ohm, that is the square root of 50 times 75. By doing so, we connect it to a 75 ohm system at one end. It will become 50 ohm at the other end, which can then be connected to a 50 ohm system to achieve impedance matching. Let's revisit the shorted and open lines we mentioned earlier. We discovered that for a quarter-wave shorted line, a value of tangent beta d equals tangent 90 degrees, which tends to infinity. What does this imply? Well, folks, do know that a shorted line is not always a short circuit. That's right. When we connect ground to a quarter-wave line, a short circuit will be converted into an open circuit. Additionally, no matter what the Z0 is designed to be, there is no improvement at all. Suppose we ground a quarter-wave line. In that case, it becomes a disaster since a short circuit at this frequency converts to an open circuit, significantly affecting circuit performance. Therefore, we need to be careful with the RF path in circuit design. Now consider a quarter-wave open line. It's fascinating that tangent 90 degrees is precisely equal to 0. What does this imply? Well, folks, did you know that an open line is not always an open circuit? When we have a quarter-wave open line, the open circuit will be transformed into a short circuit. Additionally, no matter what the Z0 is designed to be, there is no improvement at all. So we need to be careful with the RF path in our circuit design.